Hey, welcome back. In this video, we're going to be looking at multi-step problems. Now, a multi-step problem is when some object has one kind of motion for a certain time interval and then another kind of motion in another time interval. For instance, maybe an object accelerates from rest from 0 to something seconds. And then all of a sudden goes at a constant speed for another time interval. And then let's say after that, the object begins to slow down. That would be 3 different time intervals or a three-part segmented problem. So what we do in a multi-step problem is we segment it into parts. Let's read this example above. A car starts from rest and accelerates at 3 meters per second squared for 10 seconds. It then travels at constant speed until it has traveled a total distance of 500 meters. How long does it take to travel the entire 500 meters? Okay. So the first time we read any question, it's for concept. This actually has 2 concepts in it. Well, if a car starting from rest is a constant acceleration problem. But then it's also mentioning that it's going at a constant speed. That's a constant velocity problem. So it's a little bit of both, and since there's 2 types of motion in the problem, this is, as the title would suggest, a multi-step problem. So we read for concept first. Now we're going to chart it up. There's only 2 segments to this part. The first one, you're starting from rest, so the first one would be constant acceleration, and then the second one would be constant velocity. Now, once you determine what your 2 parts are, then you make your appropriate list of variables. So for constant acceleration, we're going to make this list of 6 variables every time. So let's list them. X naught, which is always 0 unless the problem states otherwise. We always start at the starting line of 0, right? The problem says otherwise, make it 0. V naught, A, and T. Now, since there's 2 time segments, right, a part 1 and a part 2, I'm going to call this T1. All right, now let's start filling some stuff out. Car starts from rest. What does that mean? That means V naught, the initial velocity, is 0. Accelerates at 3 meters per second squared. That's A, your acceleration, for 10 seconds. There's your time. So we know T1 is 10 seconds. It says it then travels at a constant speed until it's traveled a total distance of 500 meters, meaning the total distance traveled is 500 meters. That means this X plus this X have to do what? They have to add up to 500 meters. Okay, so we'll get to that in a second. How long does it take to travel the entire 100 meters? So one of the things we're going to need to do, let's list the variables for constant velocity. We're going to be X, V, and T. It's only 3 variables. We don't know how far this is, but I will tell you, once you figure out X1, how far you accelerate, you know that the remainder of the 500s must be X2. Okay, we don't know what V is, but if we figure out what the velocity is, when you accelerate from rest at 3 meters per second squared for 10 seconds, we should be able to figure out the constant speed the rest of the way. Because whatever the final speed we get here is the same as the constant speed we get right here. Okay, and then time, we're going to call that T2. So we have a few things to find. We don't know this, we don't know this. We're going to need to find both of them. Okay, so let's start off with, let's find the speed you're going at. Okay, so if I want to find the speed as a function of time, I can use that equation up top. So we'll go V equals V naught plus A times T. V naught is 0. Remember, we're starting from rest. And V is going to be equal to 3 times 10, or 30 meters per second. Okay, now that is going to go right there because that would be your constant speed for the rest of the way. Okay, now we also need to find how far we went in 10 seconds. Well, to do that, we can either use this one or we can use this one, either one, because we've got the final and initial velocity and time. I'm going to go ahead and use the third one. It's a little bit quicker. So we have x equals x naught plus v naught over 2 times t. And the reason I say it's quicker because a lot of stuff usually cancels in this equation. In other words, x equals v times t over 2, which would be 30. Oops, sorry about that. 30 meters per second times 10 seconds. You can see the seconds will cancel. Divided by 2, so we have 150. Okay, so if I know that we go 150 meters, that means x2 is going to be what? x2 is going to be 500 minus 150, right? Because it's the remainder, which would be 350. So now we need to use this to find T2. Once we find T2, we can add our total times together to figure out how long it takes to travel the entire 500. So we can use now x equals v over t2. To solve for T2, we're going to swap it out. Remember the good old switcheroo. And T2 would be equal to x over, or sorry, v. My apologies, I have the equation backwards. It's velocity equals change in position over time. Switching it out, we're going to have x over v, which would be 350 meters over 30 meters per second. See those cancel? Take a second to put that in your calculator, if you would, please. You should have gotten something around 11.7 seconds. Now, that's not the final answer. What that's going to help you do is get the total time. Now, the total time, right, is going to be T1 plus T2. Got to add them up now. Okay, which would be 10 seconds plus 11.7 seconds, or 21.7 seconds. I hope you found this video on multi-step problems to be helpful. Thank you. See you next time.